Okay, hello, hi guys. My name is Li Huang. I'm a Gov techie, and I'm part of the team that organizes STACK Meetups. We're doing this almost like every Thursday, and currently we are running every first Thursday of the month as a AI community session. So welcome you guys to join us every first Thursday of the month. Today, the topic that we're gonna talk about is about data reality and how this shapes AI development as well as the outcomes that we engineer in AI solutions. So just before we start, this is actually a new space for us, for our regular community members. If you need to find the toilet is actually in that corridor at the back. You'll be able to see a sign. And similarly, today we'll have two presentations and then followed by a fireside chat. That would be a kind of free-flowing Q&A session. So as our speakers have a conversation about the topics that they're going to address today, feel free to put up your hands, add on to the discussion, share your perspectives. We're happy to hear more from you guys. So for those who are here for the first time and new to our community, this community is actually an initiative by GovTech. And what we're trying to do this year is we're trying to pilot a few specialized sub-communities. And each sub-community will focus on a very specific tech domain. So we actually have a sub-community for data. The one that you're here for today is on AI. And then we have another track for engineering. So if you want to find out more about the tracks and what we're talking about at all these sessions, I welcome you to scan the QR code up front. This is our Telegram chat, so you'll be able to get all the latest information about our meetups. So I'll stop here for a bit if you guys want to scan the QR code. Okay. So our team is also involved in a big event this year. It's actually the STACK conference, and it happens once in 2 years. It's actually GovTech's hallmark conference, and this will happen in November. We welcome our community members to contribute to the content that will be shared at the conference. So we're actually calling for proposals at this moment. If you're interested, the submission deadline is on the 29th of May, and we'll be calling for proposals. We're seeking proposals for all these categories. So for workshops, plenary talks, and also lightning talks. For the technical workshops, we're looking for proposals on a one-day workshop. This will happen on the 3rd of November, whereas the plenaries and lightning talks, it will happen during a 2-day conference from the 4th to the 5th. So if you're interested, I welcome you to scan this QR code and submit your proposals. We are addressing 5 topics at our conference this year, and you'll be able to read more about the conference at this link. All right. Okay, so I won't say too much now. This is the program that we have today. We'll have 2 speakers with Ale. He'll start first, and he'll talk about doing useful AI, far from the happy path, followed by Sylvan, who will come in to talk about some use cases on how data reality actually affects outcomes and the impact of AI. And then we'll go into the fireside chat, which I explained just now. It will be a free-flowing kind of discussion. As our speakers are talking, feel free to chime in as well. We're happy to hear your perspectives. And I'll hand the time now over to Kian Chan, who will talk about, give a bit of an introduction on what the AI practice at GovTech does, and also lay the background on what the session will be about. Thank you.
Hi, I'm Kian Chai. Thanks for joining us on a public holiday eve. Okay, I'll just quickly explain what is AI practice in GovTech. So fundamentally, we're actually a team that actually does a bit of applied research. Okay, so we work on basically the upfront AI technologies. So we do a bit of scanning, experimentation, and then we bring it out to the government agencies and also to events like this. Okay, so there are basically 5 squads there. We cover responsible AI because AI is a lot about trust in government. AI performance, AI infra ops, and multimodal AI, where Ale comes from, and he'll explain a bit more about what that is. And of course, the strategy and engagement part of it house. Okay, and fundamentally, we do experimentation not alone, but also with a community. So these are some of our collaboration partners. Okay, just a bit of what are the projects that we work on. I think some of you all might be familiar with LangBuddy. That's an AI bot that will come to help your kids actually learn oral. So this prototype actually came out from our group initially, and since then it's been taken over by MOE. Okay, we also do a bit of basically test beds with pre-release features like Google. And I think recently there was this thing about CCTV in construction site for safety. There we actually don't really develop the thing. It's developed by industry. But what we do is we actually develop the techniques to do the benchmarking to help MOM and our downstream groups to actually basically know what's the best buy to do. So these are some of the things that we do. Okay, and in addition to that, we create frameworks. So the hot thing right now is about agentic AI. So this is one of the things that we are doing, which is basically about assessing risk with the agentic systems. Okay, so this is still work in progress, but it's recently been published in the AAAI conference that held end of January. Okay, so these are some of the government agencies that we work with and some of the partners that we work with. Okay, and yeah, so why apply R&D? I think in the past 1.5 years that we have teamed in, we have published about 10 papers, of which 3 were actually in Spotlight. And we actually present a lot of different events, both locally, like Google Dev Fest, and also internationally, where we represent Singapore in the UN conferences. Okay, and finally, we do have our own community space called Lorong AI. I don't know how many of you are familiar with, where we actually share about AI events, and we run about 3 events a week. Okay, so in case you want to know what we do, conference papers, playbooks, technology blogs, we have a blog there, all Lorong AI. Scan this QR code, then you have access to all the various information. Okay, and finally, in case you want to collaborate with us or reach out to us, this is the second QR code. Sorry, there's a lot of QR code. I promise you, this is the last one that I have to share. Okay. Okay, thank you for joining us. I'll pass it on to Ale right now to excite you on what data is all about. Thank you.
Thank you, Kenchai. Thank you.
Okay, that's me before I cut my hair. And so I know that I spoke with some of you already today. Thank you for coming, by the way. We're going to try to make it as entertaining as possible. And we want to get your feedback later. So that's why the fireplace chat side thing is fun. And this is just a warm-up for Sylvain to go on and just like show you all the stuff that you can do with AI. So I intend to present to you with some ideas. Some are a bit maybe different from what you heard before. I intend to provoke some contradiction. And I think the idea is that we're in the middle of a big change coming for us, for our jobs, for the good, hopefully. So I'll just try to walk you through it. If you have any questions, let's try to save it till the end, and we'll have a long discussion at the end. And please let me know what you think. Okay, so typically we all know what like good looks like, right? We're talking about having data quality, having governance. It's like doing your homework, eating your vegetables. But the reality is that not all the companies have this, right? Like most times you're not in the happy path. Your company has some issue, your data's not available, data doesn't exist. So now that we're talking about agentic AI, even chatbots, ChatGPT, all these things, there's 2 big points that I want to present to you today, okay? And they are part of what I think is the new curriculum So maybe just a quick show of hands. Any of you is, or at some point was, let's say a data scientist or data engineer, data analyst? Do we have anyone? 1, 2, 3, 4. Okay, I didn't see more. But a lot of us have now been promoted to AI practitioners. Congratulations. So we need to handle a lot more things. At the same time, coding is going away. This is, I think, at least from my perspective, a reality already. It's not like one day. So I want to walk you through 2 different things to consider, okay? I'll try to make this interesting. So the first one is, what happens with data that just is not there? And I'm not saying data that you cannot get. I'm saying data that does not exist. What if you could have, let's say, a video of your machine breaking down? What if you could have the sound or of the voice of your customer, etc.? Things that you're not recording perhaps, but that if you could have, you can make great decisions. The other one is all this data that we have in our heads, right? We work for our companies. We are our companies. So what happens when someone leaves? Or what happens when someone new joins? There's a lot of information gaps there, okay? And that I call the ethnographic direction. It's information that is in people's heads. And how do we expect to bring these new agents to come and act well when they don't know all this, okay? So we need to think of these 2 dimensions. And today I'm gonna be talking a bit about these 2 topics. So let's see. Yes, I just said this. Great. So what is the first part? The first part is this ethnographic idea, is the knowledge in people's heads. This is very different from a SQL database, first of all. This has to do with information that you think you know, that maybe you're an expert. You just don't think you're an expert. But turns out a lot of people in your company don't know this. You do. So that makes you an expert. Then it's information that is usually undocumented, old. Maybe there's a PowerPoint from 2022 that someone made. That's all we have. You know, this is not great. And more importantly, this is context dependent. This is the difference between your company and the rest of the world, okay? So you can go right now, open Claude, ChatGPT, Gemini, ask a question about the world, you probably get a good answer. Ask a question about your company or your specific use case, likely not so good. This is the difference between getting the vanilla intelligence and the intelligence for your situation, okay? So that's why it's important. So how can we work with this? So I don't know if there's a proper term for this. I call it knowledge ops, just like there's ML ops, DevOps. These are more ops for you. And this is good news because this is a new job role. We're going to need more jobs. So first of all, how can we structure this knowledge? And this is, by the way, our new job. We need to structure this knowledge. So this means we need to capture it. For example, we can use what's called Markdown language, which is plain text. It's not Microsoft Word. There's no formatting, hidden invisible text. What you see is what you get. Secondly, we need to treat it like we treat code. We need to make sure we have backups, that we have tracking of who made a change when. We need to know the metadata. What is metadata? Metadata means things like, when was this last modified? Who modified it? What was it before? Can I roll back to the previous stage? Then, how do we know this is good? We must test. So, in order to test, we have to do something like unit testing that we do for software. So this is, in this case, we're talking about benchmarking questions. So let's say we're testing our new chatbot. Our chatbot is supposed to give you information about how to apply for leave. There's probably a list of questions that you can think about that, well, the chatbot better answer these questions well. Okay, that's the kind of questions we're going to use to test. This is not a full coverage, but at the very least, it should cover this. And finally, any agentic solution needs to be monitored. We need to know how it's working in production. So this whole idea of knowledge ops is for you to structure knowledge, maintain it, and make sure it's correct. We'll see why later. Okay, Now let's change gears. Let's talk about the second topic. I was talking about data that does not exist. So this is a very new area. This existed, but in a very numerical capacity. So before generative AI, let's say before ChatGPT, that's our way to divide the time, right? It's usually before COVID, before ChatGPT. We had synthetic data generation. Absolutely. We can take a distribution, we can sample numbers randomly, and we can say, for example, well, everyone here is probably between 1.5 meters tall and 2 meters tall, right? And we can just sample randomly and we'll get a realistic number. But that is not everything, right? What if we could generate voices that sound like people? Images, I'm sure you've seen deepfakes. We can just use them for good also. What if we can generate situations that are unsafe? So we can then test our computer vision models to catch people getting harmed. So there's a lot of things we can do. And this should make us think that using compute or tokens or whatever we're using to generate, this needs to be managed. So the main idea here is that we need to find ways to generate data that makes sense. So there needs to be a sense of taste. This is a word that's not used very much technical language, right? But having taste, having a domain expert that know what good looks like. And it's not just like, well, the mean value. No, this is a lot more than that. So we need to encode this into what we use to generate data, and we need to manage it just like we manage data with data engineering. Okay, so what else we have? Okay, I'm going to give you a recipe. So a lot of you work in companies that have very strict data policies. So do I. And we cannot happily copy data out of the company or move it around. We need to be careful. And on the one hand, we want to use these generative AI tools. Not everyone has access to a GPU or your own compute cluster, etc. So how are we going to bridge this? One example is think of keeping the privacy and how much can you recognize what you're doing after you process it through AI. What does that mean? A bit complicated. Let me break it down. So let's say I have a video, and this could be a video of your factory, a video of something that you wouldn't want to put on YouTube, okay? It's something that is company PII, okay? So what if I say, well, we're not going to use the video, we're going to use a description of the video. This is what we call a text intermediary. So think of someone who's describing to you what the factory floor looks like. Maybe they don't remember the brand of machine, how many workers were there, but they give you like a very good description. Based on that, we can go ahead and generate a new image or a new video. You might be wondering, well, that depends how good the description is, right? If you tell me, yeah, this room has like a few walls, a few screens, Gemini, make me an image of this. Very different, right? So this is where we need to start thinking of, again, this metadata. So what we want to think of is not like just one huge model that can know it all. That is bound to fail. We need to think of perhaps many smaller models that we can even run ourselves or fine-tune ourselves so that we can then create the different features. So for example, let's say that I have this camera right here, and I'm using this image. One model is counting people, just counting how many people there are. Another model is getting a sense of where they're seated. And a third model, perhaps it's like telling me how many are asleep, how many are still eating pizza. Okay, using these three things together, we can pipe them back into a generation. So what I'm describing here, applied to your use case, could be the specific information of your company. Maybe it's like a type of part your factory makes. Maybe your model is capturing a certain sound in a certain frequency. Could be a microphone, not a camera. But the point here is that you're extracting features from different sensors and then putting them back together, potentially creating new data that resembles reality so that if you have taste, you can appreciate that it's as good as reality. So one more example of this, and this is a video example. So we can just do what I just said. We can start with a description, having text, make an image. We can then take the image and make a video. After all, a video is a collection of images temporarily stringed. And then we can train what's called a LoRa. It's a low rank adapter. This is a fancy word for just saying a customized version of the model. So maybe, let's say that we're talking about traffic safety. This is a made-up example, by the way. And we want to detect people driving dangerously. Well, we could ask one of the popular models to generate this video straight up. But what we'll get is likely a lot of different videos. Some will be suitable, some will not be suitable. But what if we curate the very best? And then we fine-tune our model with this. Then we can go and generate more videos of only exactly what we wanted. And then that's our AI. It's not the one coming from Gemini or OpenAI. It's our own version. And doing this doesn't require to break the bank. Sure, you'll need graphics card. That's like the new normal. We all need to have access to graphics card. But that bar is increasingly getting lower and lower. And it's peanuts to what costs to run a company. So keep that in mind. So I'm just going to give you an example of how I would do it if I had like to start doing this tomorrow. The first one is you start from the right, which is Cloud API. This is when people say, I asked Gemini to make me a video. That's what they mean. You're probably paying by the token or by the second. And a video probably costs you maybe $2 for 5 seconds, something like that. Maybe for personal use it's expensive, maybe not, but for a company, this is nothing. Of course, this is on the internet. So anyways, you are getting the video, you're not sending it. So analyze that. Second step, let's say you start to get familiar with this. Well, you can rent a GPU. You don't need to buy one straight up. You can just go to a site like RunPod, which is public, anyone can go. Here in the government, we have the government commercial cloud that also has ways to provision this. And you can just manage your own software there. Use your GPU. Lastly, you're very sure you know what you're doing, just buy the GPU. Keep it on premise, something you can touch. And that is the best bang for buck. Okay, closing to the end. So let's recap. In case you haven't figured out where I'm going with all this is 2 different directions, sound different, but the main idea is this. Our new job is to curate knowledge. It's not to write code. We've done that. And we will have to continue to be involved with code, for sure. But our new job is to deal with this knowledge. Either we are creating it, or we are generating it, or we are finding it in the brains of people and bringing it back. Our job is going to expand in scope, be more social. And it's very different from, if anyone like signed up to work in IT, you thought you're going to be working with tickets, not talk to anyone, I have bad news for you. We're going to have to talk to a lot more people now. So that's roughly what I want to say. Yes. There's one thing that breaks down everything. And if you're only now joining the industry, this means there will be a job for you down the line. Everything I said, there's a challenge. And the challenge is this. This knowledge goes stale. And stale knowledge is poison for agents. Okay? The agent doesn't know any better. If you tell it, we have 5 items in stock, it will believe you. It will give the wrong answer. If you say that the meeting was Tuesday and not Wednesday, it will believe you. So if your knowledge base is outdated, if your data is not there, or your generation is poor, this all falls apart. There's no agentic AI revolution if we don't sort this out. This will all be an exercise in spending money in GPUs. So I really want to be stressing this point. We cannot get this wrong. If not, we have no agentic AI revolution. Okay, so 2 examples from government that if you are anywhere in the whole government, you'll have access to this. One is a platform called AI Bots. You surely have heard about this by now. The main idea of AI Bots is to take this knowledge base, this context I'm describing, putting it together with a prompt, which is the main command, and with questions that a person might have, and just chat away. This is a chatbot. It doesn't do anything. It only talks. So it can hurt you as much as you let it hurt you, whereas agents can really harm you. So this is the main idea of AI bots. Of course, we can couple it with any of the sources of intelligence. This could be Anthropic, OpenAI, Gemini, etc. And that's the main idea of AI bots. And then the second one is a brandly new release called Platform AI Studio Pro. And the main idea is to try multimodal capabilities. This is, again, only for the whole of government. If you try to access it, not in government, you will not be able to see it. But it's a suite of capabilities in multimodal AI. So this could be video generation, image generation, podcast generation, voice cloning, the counting birds. There are so many capabilities. It's crazy. I'm not making it up. We have counting birds. So this is my QR slide. For the price of one slide, I give you 4 QR codes. If you want to take a photo, this is the time. And take note that there's parts that are accessible to everyone. So what's accessible to everyone is this. Is our multimodal AI handbook. I was one of the editors. And what it covers is how should you get started in scoping a project that involves multimodal AI, even if you never worked in this before. Secondly, is a blog post from last year that somehow is still relevant, which is essentially how do we do the knowledge operations to keep our knowledge fresh. So with that, I thank you very much, and that's the end of my talk.
Thank you, Ale. All right, next up we'll have Sivan. The stage is yours.
Thank you very much, Ale, and great to be here. Welcome, everyone. I will talk about data quality, the influence on models. So I will present you different models and different use cases we did and talk about the data challenges we faced in those and how we solved them. I think a lot of you have heard about this saying, a model is only as good as its data. And to those of you who have not heard about this saying, they might have heard about the less elegant version of this, which is garbage in, garbage out. If you've not heard of this, I have an easy way for you to remember it. And so around 2 years ago, I gave a talk on exactly this topic, garbage in, garbage out. And back then, stable diffusion was the model. I don't know. Does anyone know stable diffusion? Some people. It's an image generation model, the same thing as you can do now with ChatGPT or Gemini, but it was like much earlier times. And so I went to Stable Diffusion and I said, generate an image of a computer where garbage is fed in on one side and garbage comes out on the other side. However, you might have noticed I misspelled garbage. And well, the model took me literally, and this is what it generated. So I don't know, I think it's like cabbage garbage, not fully sure, but I think it's the perfect example of garbage in, garbage out. Like I gave it garbage and it output garbage. And so you can never forget this saying. Perfect. About myself, my name is Silvan. I'm a principal data scientist at Sulke. Sulke is the company who no one knows how to pronounce because we're originally from Switzerland and our founder, 1968, didn't think about that at some point it will become a global company. And so he chose his last name as the company name. And now a lot of people here, especially in Southeast Asia, struggle with our name. Nevertheless, we are in Singapore, Vietnam, and Hong Kong here. I will walk you through different project examples which we did and highlight the data challenges we have. And the first one is for an insurance company in Eastern Europe, which is called Unica. And there we had a lot of problem with implicit knowledge. Let me quickly highlight you first the challenge they had. So they're an insurance company, a rather large one, and you're all customers of insurance companies, right? And at some point you will send them some questions. And like, is my cat insured? Or if I travel and I break my leg, how do I get home? Like the typical questions you might ask your insurance company. Well, given the size of Unica, this really adds up. And so they have a lot of people who are responsible for answering these questions. Like 2,500 people who just answer these questions, among other things. And so around 2,000 hours spent per week just answering questions. And so, well, ChatGPT came out and they thought that's the opportunity now. Let's build a chatbot which answers these questions. I think not a rather unique idea. I mean, back then it was great. This is the thing we built for them, RAG. Has anyone heard of RAG? I think some people have. Then I quickly explain it in more detail. So RAG stands for Retrieval Augmented Generation. And so the idea is that you want to answer a question, for example, how can I insure my cat? And the answer for this is somewhere in the data on the bottom left, the policy data in this case, like the general terms and conditions for the policies. And I mean, the LLM on the top right does not know about this because it's proprietary data, it was not trained on this, and still somehow you want the LLM to be able to answer this. And so what you do is you take all this proprietary data and you put it into a vector database. So this is the arrow one here. And so you do this with embeddings. So you might hear, if you talk with the people in this domain, you hear the buzzwords of vector database and embedding and so on. Like this basically means we take data and we make it searchable. So we put this into a vector database, and then I ask a question as a user: how can I insure my cat? This question is used to search in the vector database, similar like Google search, for relevant snippets. And then these relevant snippets are fed to the large language model. And so the large language model doesn't just get my prompt of my question, but actually it gets a much longer prompt. And Ole actually has shown this in the slide already. Like it gets a prompt of the user asked this question, and the question, the relevant contexts are, then it will provide a lot of documents, and then like the general request to the model, which is like, please answer this question using the data above and also provide the sources. And this is how, without fine-tuning, you can answer questions using a large language model on data it was not trained on. This is what we used for Unica, actually a bit a more advanced version of this, which is called Agentic RAG. In Agentic RAG, what you do is you don't have this very static setup you have before, but you have a more active agent. So when I show this to insurance clients, this is always very confusing because when I talk about agents, they always think about their agents. But agent in this context is actually a model, a large language model. And so what we did for Unica is we built these RAG subsystems for every policy, around 31 policies, and then we had one agent on top. And so the user, the typical flow is like, I asked, is my watch covered? And then this agent will ask me back, do you talk about the valuables insurance or the general household insurance? Then I say to the agent, I talk about the valuables insurance. Then this agent goes to the subsystem for the valuables insurance. This subsystem, it's a much easier problem, right? We have only one policy here we need to answer questions about. So it's much easier to make this accurate. This gives me back the answer, like, yes, it's covered under these and these terms, but only if blah, 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 blah. So these are usually very long answers. And then the main agent basically translates this into my context. We built this, and it was already okay-ish accurate when we started to build like this. But still, there were somehow a lot of wrong answers. And so we started to do the evaluations with them, and we found one issue, which is somehow there is a lot of implicit knowledge in the head of these people who answer these questions. And so let me give you an example to make this a bit more tactable. A small quiz for everyone. Like, would you say a pavilion is considered a furniture or a building? And I'm asking this because one of the questions was like, is my pavilion covered? And well, if it's considered a furniture, it would be covered by the household insurance. But if it's considered building, it will be only covered by the building insurance and not the household insurance. So who says a pavilion is a furniture? Oh, who says it's a building? Okay, majority is for building. Well, the answer, as always in life, is of course, it depends. So there is not a unique definition. And so somehow the experts of Unica, just by talking to each other and looking at what the others did, they came up with each other a general agreement in which cases it's which. And like it depends on the foundation. If this is solid, then it's more a building. If there is only like some plastic, then it's a furniture. And so like this is one of the many examples of implicit knowledge Unica had, their experts had, which the large language model didn't know. And so we asked ourselves the question, and this goes very much into the previous talk from Ole, of like how we extract this knowledge. How can we somehow structure this knowledge such that the LLM gives the same answers as their experts give? Well, lucky for us, in legal context, there is this concept called comments. So when you have a legal text, there is the option that then lawyers add comments to certain parts of this text, and this comments explains how this policy should be read. And so, for example, if there is a policy around, well, small animals are covered, I always talk about animals, I don't know why, like small animals are covered, then a lawyer could add a comment of like a small animal is a hamster or a cat, but it's not a dog, except if it's maybe, I don't know, a bull terrier or whatever, then it's still small. Like you can give a very detailed explanation. And so we started to collect these comments and started to organize them in a new database, the comments database. And there we had all the things Ole mentioned of like expiry date and revisit and who is responsible for these comments. And then within the RAG setup we've seen before, whenever a policy was retrieved where a certain part was attached with a comment, we also retrieved these comments and then fed these comments to the LLM as well. And the LLM was then prompted to use these comments for the interpretation. However, it was not just like the policy text. So the LLM knew exactly this is for interpretation. So the LLM was instructed, for example, to cite from the source documents. So like it would say, according to blah, 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 section 3, paragraph, blah, 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 you can do in this. But it was never allowed, for example, to cite from a comment. A comment is only for interpretation and not a legal source, a ground of source. So this was one of the many things we did there to extract this implicit knowledge. We did a lot of other things on data quality. So like table parsing, for those who work a bit more in this domain, usually horrible. We used vision models there. Document structure, policy mapping. Like we spent so much time cleaning up this data, but it was really, really worth it. And so this is the graph I'm always very proud to show. So when we started this project and built this first bot, it was really bad. Like 30% of the time it gave around the wrong answer. And then we started to invest. We built up this agentic setup. We started to clean the data. We started to introduce comments. We started to clean up more data. We started to reorganize data. And so with every round, we had less and less error until we reached this very magic 5% barrier. So 5% is roughly what their human experts at Unica do. So I'm not at 5%, I'm like at 40% plus. These are really difficult questions. It's not like the trivial examples I've just given. But the model, thanks to our efforts on data cleaning, allowed us to really go down there. This graph always reminds me of the well-known 80-20 principle. I think this is really very true for most AI projects nowadays, especially like with RAG. You can, with some vibe coding, within half an hour, you can spin up a RAG chatbot, you can feed in some data, and then you can ask it questions, and it will provide answers, and you will be like, wow, the future is here. But then you will at some point realize, okay, most of these questions are somehow wrong. And then you start the hard work, the actual work, where you clean up the data, where you do a lot of other stuff. And slowly you can work yourself up to have something really reliable. But building an AI solution which is really reliable is something very different than just vibe coding some AI app out and then trying to use it blindly. It's about evaluation, it's about data quality, it's about subject matter expertise, it's about user expectations. There are so many components which come in. And so this graph, the 80-20 principle, still true also in the terms of Gen AI. Okay, so this was the Unica example. Their takeaway is we invested basically a lot in data quality, a lot in cleanup, and with this allowed us to have a very, very accurate solution. The next example is from an industrial context. So this is about classifying low-quality images for Bosch Cognitive Services. Let me give you some context here as well. So Bosch itself, I think not Bosch Cognitive Services, they have this machine here on the left, which is used for product photography. So you see here some camera. So this is used if you have a huge catalog of products. You can just put these products in there, then you can close the door, and then this camera rotates around it and makes a lot of nice pictures, makes a 3D reconstruction, and then you can have your online catalog where you can showcase your products. So this is a product from Bosch. And then they had the idea, well, actually, this data could be useful not only for online shops, but it could be useful for something else, meaning spare part recognition. Because one of the big pain points of factory workers is they are sent to some factory, then they realize, oh, this is broken. This takes them like 5 minutes, and then they spend 1 hour in the web shop trying to find the replacement part, which I think a lot of us can relate. And so Bosch thought, couldn't we offer as a service to our clients a computer vision model which allows them to re-recognize spare parts trained on these images? So we take these images we anyways have for the web shop, we train a computer vision model with these, and then the service workers can just like look at the part, take one image, and it shows them this is the part you want to buy. I think you know this from like clothes shopping online as well, like there are a lot of services out this. So we did this, and well, The expectation were these really, really nice pictures, right? Well, the problem is reality, like these are the pictures from the smartphone of the people in the factory, and this is just very, very different. So these were really, really bad images, really low quality. We see it on the right. These were like blurry, weird backgrounds, not full in picture. They're just like people who didn't really care too much about these and just like quickly took a picture. And well, if you train a computer vision model on this perfect data on the left and try to predict the images on the right, it just doesn't work. Like accuracy was less than 1% on a data set with around 13,000 different classes. And so, what did we do? And here, contrary to the Unica example, we can't change the data, right? This is from the users. They take the pictures. We have some influence with UX, like we can ask them to make a nice image. We can, like, if it's blurry, ask them to retake the image. But in the end, the UX at some point has its end. And we also don't want them to prompt it like 5 times, please do a picture again, please do a picture again, please try it again. At some point, they will just not use the app anymore. And so, well, the solution is, if our test data doesn't improve in quality, we have our train data to make it worse in quality. So basically what we did is we just started to make our train data really bad as well. There are different techniques around this. Usually it's called data augmentation, but we really brought this to the extreme. So you see here this example on the right. So these were the training data, but we made them blurry, like we added random backgrounds, we cropped them, and we did a lot of ugly stuff to these images. We also did a bit, we segmented the train images such that they're always on the same thing. And so using this, we allowed the test images to come much closer together, not by improving with the test images, but by basically making the training images worse. And with this, actually, it was possible that the CNN started to generalize. Generalized meaning it was trained on this machine data and then re-recognized parts in the real world, which is always very difficult to have this gap from training data to the real world data. And so in the end, we had an 84% accuracy around 13,000 spare parts. So it could give you, from one image, it could tell you which part this is out of 13,000 options with an 84% accuracy, which was amazing. And this is the power of computer vision models. Computer vision models are really good in handling ugly data, but only if they're also trained on ugly data. And so it's the complete opposite of Unica. We didn't improve the data, but we actually make it worse. But I think this is very unique to computer vision, right? This doesn't work with other stuff. But in computer vision, you get away by just making your training data worse as well. Okay, last part is also from an industrial context. And there it was also around data quality issues. So let me give you some context. I can't name the client here, unfortunately, yet. Like we're still in the approval phase of the official success story, but in a few weeks I can tell you who it is. But it's an industrial client, and they develop software for their clients. So they have software solutions which they offer as a software as a solution service to their clients. And what we built for them is an agentic AI solution within their software. So this is the architecture, a bit anonymized. I think the important part here is you have some main agent, and then you have different sub-agents, and these sub-agents interact with the data in Elasticsearch of the client. So in Elasticsearch is the data of the clients, and we have one agentic AI system which uses this. And well, here, surprise, surprise, there were some clients which had great data, like really nice data, and then there were these clients who just had really bad data. And, well, I mean, they had missing data. So they had like perfect columns, but then there was just no data in there. They had very inconsistent representations. They had free text fields where people just entered stuff, like a lot of typos, and just like really bad data quality for some clients. For others, the quality was really good. The problem, again, we cannot control this data. The data is from the client of the client. They will not change it. And so we have to work with this. And how can we do this? And well, what we did is we used an LLM to actually to map this data. So we have this customer data. It's of questionable quality. And then we create an index description of this data. So a very comprehensive description in text, which explains, well, this data has these, and these columns. This is the data type of these columns. This column is actually empty. In this column, you have usually these, and values. This column is free text. This column is an enum. So a very detailed description of anything we can automatically derive from the data without any metadata. Just like a very rich index discovery. And then we feed this index discovery to an agent again. And then if the user comes in with a request, so for example, I want to see all pumps, like this industrial client, they might want to search for pumps. So it asks for all pumps, and then the agent looks at this index description, and it starts to see, pumps, we have a field called type, and that is an enum, and it has value pump as well. So let me filter for this. And then it creates a filter in Elasticsearch. This filter goes, the agent looks at the results, and then like a human, it can start to interpret. So, this is unexpected. I think I have to refine my filter. And like there is a certain amount of intelligence in these agents that it basically looks like a human on the data, on the results, starts to fine-tune the filter, searches again, goes in rounds until the agent is convinced, okay, this is actually what I want to do, and then it returns it to the user. I have a small example here. This is from a demo app. So like I ask it, show me all incendiary air blower discharge silencers. And then we see on the right the debug steps. So what's happening is this agent thinks about this. It asks about these air blower discharge silencers. Then it creates a filter, which you see on the bottom, where it uses the different fields of the database. Like it filters for silencers, which is like a type. And then it searches for other fields like incinerator, blow, discharge, and like creates a filter. This runs on Elasticsearch, and then you see the results. And you might see when you look at the first result on the bottom right that there is, for example, a typo in there, like it's Silsener, not silencer. But thanks to these approx filters, the LLM was able to still recover this, and so this is then returned to the user. And it finds these two silencers, the 77S, 7706A and B. And this without having any knowledge about the data. It just gets a generic description of the schema, and then based on this is able to craft these really powerful filters we see on the right. Okay, let me try to wrap this up. So we've seen two very different approaches to data quality issues. One is that if we have high quality data, we get really, really good outputs, and also the opposite, like if we don't have high quality data, garbage in, garbage out. On the other hand, even if we don't have high quality data, actually AI can, in some situations, still handle it. Computer vision models, for example, are really good in handling low quality data. And with LLMs and agentic AI, you have some options to mitigate some data quality issues. But there is a certain threshold. At a certain point, like if values are obviously wrong, this is just like, it will not work, as Ollie mentioned. If you claim you have 5 of this type, the agent will say you have 5. And if it's actually 4, you cannot recover from this. But if you have a typo in there, or if a field is named a bit weirdly, or whatever, then the agent is sometimes able to extrapolate from this. And so if you're wondering now, 2 years later, the Stable Diffusion image was 2 years ago. If 2 years later, I now go to Gemini and ask exactly the same question of like, create an image of a computer where garbage is fed in on one side and garbage comes out on the other side, again with a typo, what you get out is this, which is actually much closer already to the true thing. So it shows a computer, it shows garbage, but somehow it misspells garbage. So I think it's, again, the perfect example of like garbage in, garbage out is not as much garbage as 2 years ago, but it's still not perfect. Perfect. Thank you very much.
Thank you. Thank you, Sivan. All right, so we'll go on to the fireside chat. Just give us a moment to shift the chairs in. Yeah, so if you have any questions, you can ask along the way. We'll have our speakers have a more casual chat about their presentation.
Okay, so we spoke for a long time just now. And I'm super glad you're still here and alive. But first of all, thank you, Sivan, for the chat. Super good.
Thank you to you.
And I have some questions prepared for Sivan, but frankly, I would much rather hear from you. And I spoke with some of you before the session started, just to get a sense of what brought you here. And maybe we touched on some of those things, maybe we haven't. So I'll just start with 1 or 2 questions. But if at any point you have any questions, raise your hand and we can talk about it, even if you're not sure. I know this is new for a lot of people, so don't worry if you have like a half-cooked idea. My mom told me about something, like, it's okay. So maybe, Sivan, I started asking you a question. So just now you walk us through different scenarios in which the data was in, let's say, different levels of quality or availability. And you bring up this idea of 80-20. maybe could you explain what was this first successful 80% with 20% effort? And then what was the flip side of that?
I think the first example was when we just quickly, in 2 days, hacked together a prototype which had this agentic AI structure already, where you could ask some question, and then you would go to the right sub-agent. And I looked at this and was like, oh, really nice, because this was 2 years ago. It was really, LLMs were very early stage, right? And you saw this agentic AI function calling just came out and was like, wow, it's amazing that this works. And then I basically showed this to the client. And then the client asked, I think, is a photovoltaic system covered? And then the main agent went to the photovoltaic subsystem. The photovoltaic subsystem said, I don't know. And the main agent was like, yes, it's covered. And then I was like, oh no. So this was, I think, the first realization of, okay, we are at this 80-20. It works, but still there are very weird issues.
Okay, thanks for that. Any questions? Okay, just now, I'm going to try to remember the people I talked to, and probably it's going to be in the reverse order. So I think one of the guys over here, they're just starting out. They're going to start uni soon. And they were asking me, how do you get started in this topic of AI? And what can they do, given that they're only now starting university? What would you say is the first way to get started?
So university as a data science major or?
Computer science and data science.
Yes. So, one part I think is that you should not skip the fundamentals. I think that's very inviting at the moment, that you see, these things, the AI, it works so well, let me just jump to whatever. You should still learn the fundamentals. Especially around evaluation. So when you learn data science before ChatGPT, I learned a lot about how to properly evaluate the system, classification and regression. You learn the different metrics of precision, recall, F1 score, blah, 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 for classification, and for regression, root mean squared error, all the different ways how to properly evaluate it. And we learned a lot about how to train models, which is maybe a bit less relevant in some circumstances. But the basics, especially with evaluation, I think are still the same. You cannot improve what you cannot measure. And so if you don't know how to evaluate the system, which is basic data science knowledge, you will never be able to improve it. And so I think this is something which separates, let's say, someone who comes from software engineering and implements some AI solution for the first time and basically thinks about this as a software problem where it's just mostly about connecting APIs. And someone who comes from data science, who has a bit more an understanding of it's not just about connecting this stuff. This is a stochastic system which is not always producing the same answer, which is, you cannot just unit test this and say good to go. You have to do benchmarking. You have to look at how accurate is this? Is this in 95%? And so these basics, I think you should still learn. And you learn this through the typical data science courses, yeah.
Thank you for that super comprehensive explanation. One more thing I will add to what he said. So do what he said first. But then think of it like this. Business lives where the data science helps make money, save people, optimize something. That needs to be measured. And you can tell when someone is just trying to smoke you, trying to convince you something, when they don't do evaluation. So when you see someone who just claims, oh yeah, this is 99% correct, and you ask, what's your precision? What's your recall? Oh, I don't measure. That means that that's probably a lie. So learning evaluations is super important. And that's how not you, maybe a data scientist, but the business owner makes a decision. Because if you have to make a decision this model will cost 10 times more, is it worth it? How do you know? That's a business decision. That's money and time and employees. So data science sometimes is at the intersection between business and data. And some decisions are not data science, an algorithm told me, a mathematical theorem told me. It's a money decision. And that's why you need to measure so you can make those decisions. Any follow-up questions?
We're both just starting university. So is there anything that we should be doing besides studying the fundamentals? So what kind of projects should we start working on? Or what kind of internships should we look out for to help us in our future?
Okay. Great question. You can do a lot, so don't worry about covering everything. It's impossible, let me just tell you. But what you can do that I think is wise is try to understand how companies exist. Like, how do they make money? How are they better than their competitors? And how does that translate into problems that data can solve? Because if you understand that, you are already one step ahead. You don't need to be told what to do. And that will help you decide what tools are relevant, what problems deserve to be solved. Like, should we use a super GPU to solve something irrelevant? Definitely not. It could be very fun. It could be very interesting. But just because it's interesting doesn't mean it's worth doing, especially from a very money, like cold-blooded mentality, right? So I would say get involved in how companies run. It could be a non-profit, doesn't need to be like a bank. But the idea is that you understand why does this service exist in the world and how can it sustain itself?
Yeah, I think I have a much more calmer time if for most of the things which pop up on my timeline of like, oh, we have this new framework, this new library. I'm just like, well, I can do with this library the same thing as I can do with the last 10 libraries. I will be equally efficient, and so I will just wait. And if in a year it's still around, then I might use it. And so I think this makes you, maybe like waiting with these helps you a lot.
Okay. Sure. There's a question that I spoke with someone earlier, and by the way, this is not rehearsed. So if you see, like, he's like blink twice if you don't know. Like, so someone earlier told me, we're in Singapore, many languages are spoken here, and this is a consideration more from like a public sector. But anyone really that interacts with the public, a company also needs to be aware of. Like, and Singapore has like 4 official languages, many more are spoken. How should we think of large language models that are, mainly in English, American English, British English? How do you think we can consider like differences in language? And like, should we, like, is this a problem? Like, do you think these models perform differently if you communicate to them, let's say in Mandarin or German or plain English? Not sure if you have any comments on this.
I mean, maybe 2 parts to this question. I think one is just that for certain languages which are less present on the internet, it just fundamentally works worse than for especially English. And so this is for sure a problem, right? There is quite an awareness of model providers around this. So they try to boost also less represented languages in these models. But at the same time, it's like a business decision. If you have from certain languages just a handful of users only, you as a model provider will not invest a lot of money in like making your model good on this. The other part which I found, so this is like the obvious thing in the sense that when you use it, you immediately recognize it doesn't work well. The other thing is that you have very often hidden assumptions in these models, right? That just today we had a workshop at the MedTech company, and then we built some prototype, and then we asked it to have example data of hospitals. And it automatically assumed that we are located in the US and just only provided US hospitals, right? And so this was this just default assumption that the model is probably used in the US context, whereas here this was not applicable at all, and we had to recreate our prototype. We lost like half an hour, it's not bad. But I think for me it was again this learning of this implicit assumption of the especially US centricity if you use US models. And yes, I think that's something you have to be aware of, because otherwise you have to nudge the model in the right direction. Otherwise it will assume the majority, which is usually US and English. Yeah.
Thanks for that, Silvan. Yes, there's a question over there.
Hi. Okay, Cyril here. Thanks so much for the presentation so far. I have a question because in one of the models that we showed, you had a main agent that would then interact with sub-agents, and these sub-agents would have access to specific data set. My question is, how did you define the scope of each agent, and why would you have, for example, an agent interactive with only a specific data set, rather than leaving it to have agency on where to find the data, for example?
Yeah, it's a very good question. The honest answer is probably estimated guess plus trial and error, in the sense that we had it was not separated by data sets, but by like domain parts. Like usually in this facility, you have also different experts, right? And they have different domain knowledge. And so we try to separate it as well. I can't unfortunately give the too detailed which one we used, but basically it's separated by things which also maybe humans are knowledgeable in. Why we did it is these schema descriptions, they're quite heavy. And so you cannot feed just like expose an agent to too much information. So you have to, this agent has to solve a lot of different things, this main agent. And so you will overwhelm it if you try to explain everything to it. And that's why we used these sub-agents to like make the life of the main agent a bit easier. Like the main agent basically just needs to figure out which sub-agent can take care of this and then like delegate the task and then come back. Yeah. Which is by the way, very common thing. Like you have a main agent at a certain point, they are overwhelmed because there is just too much context, and then you start to try to break down the problem. And one way of doing this is with sub-agent. Another thing is with agent skills is also a possibility for this.
Hi, can I just ask, you're showing your RAG and you base it on vectoric. Have you ever tried basing it on graph, like Microsoft Gremlin or Neo4j kind of graph? Yeah.
We have done some experiments, especially because there are certain links in these policy documents. So like, for example, you have a policy about something, but then you have another policy which has a list of exclusions, and then there are like, again, another policy, like, so there is a certain link between policies, and there it's beneficial to represent this then. We model this then quite explicitly, like, so if a part of this policy is included, then we will also include this one. And so this is, I guess, the closest to graph RAG. There is this idea of graph RAG as a more black box problem. So this is just you put in all the data, you use LLMs to create some kind of knowledge graph out of this, and then you use this. I think this is still a bit controversial if this really boosts accuracy. I so far was a bit reluctant to use them because it's very difficult to update these graphs. Like you can create them, you might get a performance boost, but if one of your source documents changes, it's quite difficult to recreate your graph, especially if it's a dynamic creation process, which could then result in a very different graph. And so I've still considered it quite researchy, this whole concept. Yeah.
Okay, actually, I have worked with GraphRag before, and I disagree a little bit. So, you're absolutely right. Keeping the graphs updated is the biggest issue. But maybe for people who have never used a graph before, the idea is that the data is connected. And the connections you can analyze in English. So for example, Bob works at Apple. So that's a sentence, but Bob is an entity, Apple is an entity, works at is a relationship. So you can then start inferring things that you wouldn't know. So the typical problem for graph is, who's my neighbor? So one example is you open the phone book, if you're old enough to know what a phone book is, you open the phone book and you start looking for everyone until you find your address. And if you have a lot of people in your country, that's a long phone book. Or you can just walk next door and find your neighbor. So the graph tells you, how do I go next door? What are my neighbors? And then you can go neighbor of the neighbor. It's kind of how LinkedIn works, you know, who's like first degree, second degree. It's exactly a graph. The challenge is exactly what Silvan said, but when you have information that is more of an ontology, something that is kind of set in stone, think of like a library system, how it's organized, you can quickly remove all the unnecessary information. So you can prune sections of the graph that are not needed. And by restricting your search space, you have like a higher chance of getting what you want. The second part is that there are relationships that are fundamentally, that the relationship between the data is what counts. It's, for example, how much a website is visited, who's visiting it. It's not when, but like who and what. Those are all graph. So I would say if your problem statement requires graph, definitely consider it. If you have a sense that the graph can allow you to prune entire sections, consider it. But the pain of keeping the graph updated is real. And that might be the reason not to do it. Thank you. Yeah, I think we have a question here.
So my question to Silvan. So your models that you've built, the Unica one and the other one, is very early in the LLM stage, right? So given today, the evolution of LLM, and how do you think your model, or how do you think you would have designed the LLMs or your chatbots, and what do you think would be your precision or accuracy score that you might have received?
Yes, so the last project presented is actually very recent. So there it's today is like GPT-4 5.4 at the moment. The Unica one, this was first with GPT-4o, and no, first with GPT-4, and then at some point 4o, and then 4.1. I think there, one of the challenges we faced back then, which are absolutely not relevant anymore now, was the context size. So these were the times of the very small models, like 8K, 16K context size, meaning we had to also optimize the whole retrieval part and chunking part a lot. Whereas now, this sub-agent, you would just feed a whole policy in there. You wouldn't care about chunking this, because these are like PDFs of maybe 3-4 pages. You just put this in there. I would still go with this overall structure, but I wouldn't. The retrieval part, I guess, would be redundant in this context. Nevertheless, the accuracy gains we had were not so much from this retrieval part, but much more from the data cleanup before this even entered the stage. So I think the project wouldn't have been so significantly easier than 2 years ago. Yeah.
Are you satisfied with that answer?
So what is the compute behind it? Like, was this deployed on some high GPU models, GPU compute systems, or was it just deployed on some regular AWS ecosystem like SageMaker or stuff like that?
This was Azure native, like everything was, yeah. So we had the OpenAI APIs and with a standard app service or container apps, I don't remember, and yeah.
Maybe one comment. I think some people might not know the distinction, so I want to unpack it. So I think the main value of the revolution now with is intelligence providers is that you don't need to have your own cloud. You can just call for intelligence, give text or images or whatnot, and you get back a response. Usually, you will have to have your own system. This could be a server room in your company. This could be something like AWS, Azure, Google Cloud that is managed elsewhere. But you will have to own it, maintain it, secure it, etc. The intelligence providers are saying, you know what, I should give you an API key, treat it like a credit card, so don't give it to anyone because it's money, but just use it for the stuff you need. And this changes dramatically the equation, because now you don't need a cloud infrastructure. You can run things on your laptop plus this credit card, this API key. This opens the door for a lot of smaller shops, small businesses, even one-person companies. So for people who are used to traditional cloud architecture and whatnot, that still stands. Like, you still need a database, you still need cybersecurity, but there's like a new layer to this. You can, of course, have these models in-house. You can host them in your GPU. You can buy the GPUs, like I mentioned, or rent them from the cloud inside your environment, your cloud environment. But there's just more options. And I think that levels the playing field a little bit more. I think we have a question over there. Yeah.
Hello. Just a basic question. So I just started learning about the machine learning software like Jupyter Notebook and R, Python and R. So I'm just concerned that there may be data leakage when I load confidential data into those software like R or Jupyter Notebook and then call online libraries or packages. Is there any accredited sources that can give assurance that there will be no data leakage when certain libraries are called or those programs are used?
Okay, this is a very important question, and the answer is it depends. So here's why. If these are libraries that are known to be safe or understood to be safe by the community, there's no stamp of approval. We just trust, and we use them on a daily basis. And this Jupyter Notebook is something running on your computer. If your computer is safe, then you can assume that data is safe because it's not leaving your environment. If you're running a Jupyter Notebook on a cloud environment, well, it depends. Are you paying for it? And is the provider guaranteeing you security? Then you're trusting them with that. If it's for free, you need to assume that that is being used for a separate usage. And the typical example of this is Google. If you're not paying for the product, you are the product, right? I have free Gmail, I have free Google Drive, etc. I know they're using my data to train their models. They're not going to send it to my neighbor, but that is definitely leaking. So I think you need to pick your risk appetite and act accordingly. If you are for sure there cannot be any leakage, it needs to run on your laptop. Like, you need to be able to touch the hardware. Other than that, you're putting layers of unknown between you and your data.
Yeah, I'd like to ask you, when you build your application and in the advanced stage, and it's a lot of code going back and forth, how do you deal with context poisoning, and the structure of the code? And then how do you ensure that along the way when people contribute to the code, it doesn't get bloated or skewered, so that you have a gold standard? Yeah, how you do it?
Okay, I'll repeat the question. Essentially, let me see if I understand correctly. As you develop with these agentic coding tools, they are very good at writing code very fast. And how do you prevent from this code to go in unplanned directions, getting bloated, out of control, essentially? How can you account for that? Because so far, these are solutions that do the solution for the customer. But what about the solutions for you, the developer?
Okay, yes, it's a big topic, and usually the term spec-driven development is then mentioned in this context. So, you might have heard the term vibe coding, maybe. So this was around 1 year ago, maybe 1.5 years ago, where basically what you said, you just put in some requirements in LLM, and then it will generate your code, and it will generate much faster technical review, and then you just say, yeah, it's okay, and then you deploy. This is vibe coding. The opposite of maybe the most constrained way of using AI is autocompletion. Maybe you have an autocompletion which you type and then it completes and then you verify. You have very tightly on the leash. So this was basically what you had to do before, I'd say, November 2025. And so there was this pivot moment, around 5 months ago, where Claude Code and now also Codex somehow became very good in, if the requirements are well defined, generating code which with very, very high likelihood adheres to your requirements. This had this whole shift into rediscovering spec-driven development, which was something it's a much older concept, which is basically you have your specs, and your specs are your ground truth, and your specs are as accurate as possible, and then your code is just an artifact of these specs. The most extreme form of this, which I basically don't think works, but the most extreme form of this is that your specs really define everything. So you spend 50%, 60% of your time writing these specs. Then a powerful AI model, like Anthropic models or the OpenAI models, generates the code out of this. But this code is then basically a throwaway artifact. You could just really delete it and regenerate it because your specs. I think in practice, a lot of people, including myself, disagree that it works exactly like this, because a very detailed spec in the end is code. So there is this trade-off between having specs which are written detailed enough that the AI will generate the code out of this you intended, but not so detailed that it becomes unmaintainable and basically is code. And this is I think it's something developers have to learn again to some extent. So this whole flow, you have then some frameworks around this, like OpenSpec or SpecKit from GitHub. But it basically boils down to you spending maybe 60% of your time writing specs and iterating with them with AI. Then 10% of your time drinking coffee while the AI generates code, and then the rest of the time looking at this code. But you will not look at it line by line anymore. You will do more like the interfaces, are they okay? General a vibe check, not really, but it's mostly interfaces and guidelines. And then this is, I think, the important part of spec-driven development. If you see something you don't like, the temptation is to change the code. And this is what you shouldn't do. You have to change the spec and then regenerate, or you have to, and yes, spec, by the way, is a broad word. Spec is a lot of stuff. But this is basically spec-driven development, badly explained. And I think this is where we're heading. You will most probably not write code anymore. You will mostly write specs and you will review code. And specs, by the way, is anything from architecture to company guidelines to, for example, in Claude Code, you have the Claude.md markdown file where you write a lot of rules in there. So spec is a lot, and it's around this context engineering such that the AI will generate the code first single, like zero shot, how you want to have it. Yeah.
Maybe I want to add, because I really think this is a very interesting question, and it affects a lot of people who work with code. And the key word right now is harness engineering. And the idea is a harness is something you put on a beast, right, to try to steer the beast. So now we have these very powerful AI models like Opus or for Codex and OpenAI, and they can do anything. So our job is to steer the beast. We cannot control it. We can only go that way. And these are the specifications that Silvana is mentioning. I heard wild ideas that we shouldn't even look at the code anymore. We should look at the specifications, at our decisions, and we shouldn't even save them. Sorry, we shouldn't save the code. We should save these decisions so that in the future, maybe the code is invisible to us. Maybe we're going back to assembler language where we don't need to understand the code. We just need to understand the decisions. This is a wild take. Maybe I'm totally wrong, but I don't think there's no one else but me that thinks this. I think this is an idea that some people are adopting, which is just decide what the important decisions are, let the model figure it out. And the second part you mentioned is testing. Because we used to write unit test, which is like, oh, if I do A plus B, I must get A plus B on the other side. Well, now we're checking based on artifacts, right? We build a website, do the buttons work? Can I scroll? What about if I'm building something a bit more complicated? What does it mean to test that? And at the same time, these models are able to, control your computer, move your mouse and click. They can make a video of that and then show you, see, it works. So this is going crazy pretty fast, but we are here already. This is not the future, by the way. Like, these capabilities exist already. So we are going to need to understand how we can test that something is done by looking at artifacts, not just code, not just unit tests, but maybe simulations, maybe videos. And this is how we're going to evaluate that this pile of code that we have not written works. Here.
Hi, I have one question. How can the identity can be secure in multiple channels? Just now you have multiple agents, and also you are talking about intermediary and all these things. How can you secure the kind of identity propagation without breaking the trust boundary? And also sensitive data retrieval and all this.
Yeah. I think there are two approaches of this. One is that if a user of a software uses an AI part of this AI has the same privileges as the user trying to access the systems. Then it's actually quite trivial. The AI can only discover what you would anyways have access to. So for example, in this industrial context, like you can then discover objects, but you access the database with the AI accesses the database with the user account of the user, meaning it can anyways only discover objects it can, so it cannot leak. This is not always possible, especially like when you have background processes and so on, and then you usually have these service accounts, and then it's much more difficult to ensure that you do not leak any information. But the easiest is if you can just have the AI with the same privileges as the user using the AI, then it's even, yeah.
I want to add to that. So there's two things to consider here also. One is that we say the AI, right? We're actually talking about different agents, and they have different capabilities, different context. So why don't we treat them like we treat our employees, right? Not everyone can access the database. Not everyone can write into the database. So we must potentially think of these agents as role-based access control for agents. So that's one. So then some are actually able to access the database. Others should be definitely forbidden, especially based on if they're on the internet or the intranet. The second part to your question has to do with preventing leakage. And this is, one point is what I just mentioned. The other one is, where is your intelligence? Is it relying on the servers in Ohio, Anthropic, whatever? Or is it in your own company secure environment? So if you're able to run models locally, that means on your hardware or your secure cloud, the data is not going anywhere. So at the end of the day, your solution is as secure as your network. So we need to assume that your network is really secure. If not, this is like a cybersecurity problem entirely. But the added risk of using intelligence providers is that your data is leaving the network if you're paying an API from OpenAI or whatnot. If it's hosted on your company, then it's inside your house, right? So, yeah. Yeah. Okay, after that is you. Yeah.
So you just mentioned about the unit testing in the traditional applications, software applications, and even in the data engineering, we do a kind of a unit testing and stuff. So when it comes to LLM and agentic AI, what kind of testing do you do, and how do you try to kind of reach to a decision like, yeah, we are confident about rolling out this particular model, and how often you do every time there's a upgrade in the model?
Okay, so I can go first. So this really depends. I think that if it's something like a chatbot or an agent taking specific actions, you have a sense of what has worked in the past. So as long as the behavior falls within the distribution, that's one. So you will have to monitor every single action. So this is MLOps all over again. We need to not only when we're building it check, but check in production. The second part is, how do we know what good looks like when it's not just like true or false? Maybe what is like a long text or it's an image. This is where the taste comes. And taste means encoding preference into metadata. What that means, in other words, is if this is, for example, a quality analysis of a piece through a microscope or something like this, then you better have descriptors of what that looks like and models that can go from image to specification. And then you check. Because an image, if not, is nothing, right? It's just pixels. It's not an entity that you can say, oh, is equal to, is greater than. You need to bring it down to numbers. So my 2 points will be that. One is you're always testing. And secondly is if your field to test is not immediately a number, you must bring it into a number through whatever means you have.
So, sorry, I self-confess is a rookie, so I don't know a lot of technical aspect. But I'm just very curious about the third case study that you mentioned about the dirty data and how you use like the schema to better the process. I just curious how much of the human effort need to be invested into all this experimentation, because we talk about AI being part of it, but I'm sure there's a lot of human investment in as well. So is there a high percentage to make sure that the schema is comprehensive, is accurate? So I just want to know what is the percentage involved. Thanks.
Thank you very much. Yes, I think the whole testing and creating test sets and benchmarking is the majority of your project even, right? Given that you don't have to train a model anymore, you will mostly spend evaluating it. You cannot test 100% because there is like an infinite amount of questions you could enter in such a bot. And so that's always a problem. But you can, like with statistical tests, gain a certain confidence that the bot will, in a certain amount of cases, give the right answer, and that the amount of wrong answers is maybe not on human level, but maybe acceptable. And so what you usually do is like you try to involve the users, especially for this chatbot thing, is because a chat interface has the problem that you can type in anything, which has the result that users always just type in anything. So like you can try to think about all the 100 use cases, and then your first user comes and he types in or she types in something completely different. And this is sometimes a bit frustrating in my job, but that's how it is. And so you try to bring the users along from the very beginning. You first, like offline, check with them what would you test, and you create some first test questions. You, as quickly as possible, try to spin up a test system. You let some test users run on this. You monitor every interaction. Based on this, you create a bigger benchmark. Then you go back to them and say, hey, which of these answers were wrong? What should have been the right answer? And so you invest a lot in building up your own benchmarks. And these benchmarks are then used as like, whenever you do something, you rerun these benchmarks and you see, does it work better or worse than before? And so, and fundamentally important part of all these AI projects are building up your test data such that you can measure if your system improves or if it degrades. Yeah.
Okay. I think we'll just take those two hands as the last two questions, and then we'll conclude for the day.
Oh, okay. Hi, thank you for the talk. I learned something new today. I didn't know this thing called ethnographic data generation. I can see that it will be very useful for government applications, but I'm also curious, will industry embrace it as well? So for the two speakers, maybe you can share a little bit more. Thank you.
I can try first and then please help me. So ethnographic, I think the main idea is that any organization, government or not, there's a lot of knowledge that is not structured and depends on the job you have. Maybe a few people have it. So that's very hard to capture. And for the new abilities we're discussing, this agentic coding development, even the chatbots, if they don't have that, what we get is like the vanilla flavor, is the same answer that, oh, assume we're a company, you must be in San Francisco. It's like, no, we're in Singapore. So this is the problem that Sylvain was mentioning. When there's no ethnographic analysis, when there's no knowledge management, you get the average. And because these models are overwhelmingly trained in English, in US, in those settings, then we get that, right? So the specialization of the models comes from this context. So what I would recommend is to think, what are truths that don't change so frequently in a company, and encode them in text. This means just writing them down as like principles or laws. Of course, companies get, change direction, change management, reorg, a lot of things change, right? So we must be diligent in updating that. Otherwise, our agents or our chatbots are as good as things were in the past, no longer true. That's this idea of like keeping it updated so it's useful. Anything else? Okay. Yeah. I think the last one for the night. This is yours.
Okay, so one challenge with synthetic data generation, right, is to create diverse data sets. Do you all have any advice on how to make sure that the data that's generated is diverse? Because from what I've experimented before with using LLMs to do synthetic data generation, even with seed text, is that maybe if you're generating a data set with 10,000 rows, maybe a few hundred rows, you'll see repeating patterns in the same data.
Okay. He's saying I should answer this. Sorry, wait, before you return that, 1 second. When you're saying your data that you tried, is this text data you were saying?
Yes, text data.
Text data. Okay, thanks. Okay, this is where it's more of an art than a science, okay? So these large language models, you probably heard, they're like next word predictors. What they do... Yeah, they're good, right? What they do is they predict a word based on a distribution probability. And you usually get the most likely word to come next. But it's a probability. You can get not the most likely. So first off, you need to move away from using fixed structures. It's like saying, my favorite number is ... That will likely be auto-completed with some numbers more than others. You can think of ways in which you can do this outside the LLM, get variation coming from different places, and then at the last minute you transform it. Another one is language. You can just use different languages and then translate them back to English at the last minute. There's a lot of nuance in every language, and how they're represented in the numerical way. You probably heard about embeddings. Some semantically are near, but when they are complex sentences, that changes everything. Think of a saying, oh, it's better one bird in hand than two in the bush. That doesn't translate to Spanish very well. So if you were to do things in different languages and translate at the last minute, the meaning is different. Therefore, they will be sampling different parts of the distribution. So you don't get over-representation. I'm drawing a normal distribution, right? You don't get over-representation of one item by artificially making it more complicated. So my suggestion to you would be, try to go as varied as possible, and then at the last minute, you converge where you want to go. Just for example, before LLMs, and this can still be done, people were using the problem of random numbers. It's actually a very tough problem because how do you guarantee they're always random, they're not repeating? So people will use like counting the temperature of a room with a very precise thermometer, or like measuring the radiation from the sun, or like all sorts of physical things that are impossible to predict and that will give you some sort of unexpected value. And then they multiply by 10, divide it by 20, they do something to it so it's in their units. So try to find ways that are creative and different, and then bring them back at the last minute. Does this answer your question? Yeah? Okay.
All right. Okay, Sivan had nothing to add on.
Anything from your side?
All good, thank you very much.
All good, all right. Okay, I guess we'll conclude the fire chat for tonight. Thank you, Sivan. Thank you, Ale. So thank you for coming. I know it's a long weekend this week. Thank you for taking time out to join us this session. Before you go, can I get your help to answer a feedback form here? It's the left QR code. Please give us your suggestions, feedback. We welcome them. And when you've completed the feedback form, please go to my colleague there at the pull-up banner. She has some freebie for you. So do claim it before you go. All right. Thank you.